know how much some of you need this grade on Wednesday. Okay, 41, not that it matters at all, but it's 41 points. I went through the test on Friday and wrote down some of the topics. Anybody have their packets here? What page are you starting on? 55? If you start on page 55, that's where the review starts. And again, I want to make sure we're clear. The test covers, let me just make sure so I don't misspeak. The test covers day 3.9 on. Okay, it's not a full unit test. Like there's no theta equals S over R. None of that's on there. So it's 3.9 all the way through to the end of the unit. Okay. So the day we started the unit circle all the way through. Jeremy, question?
So it's going to be all, so there's nothing before 3.9 on the test?
Well, I'm sure you still got to know how to put an angle in a quadrant. That's something we did before the quiz, but you still got to know how to do it to do the problems we're doing now, right? Like there might be a radians question and you'd like it in degrees. That's something we did day one of this unit, but you might want it to do the problem. All right, I can confidently say there's no, theta equals S over R. There's none of that on there. All right, sine, cosine, tangent, I taught you guys. SOHCAHTOA, I taught you guys before the quiz, but it's a big part of this unit, second half. All right. All right, so this is just some of the topics right here. There is another page of topics, which I'll get to. Anything on this part here or anything in general, the homework from the other day when we did secant, cosecant, cotangent. How about we start here? Some of the basic facts I'm going to need to know. All right, some of the basic facts that go, if I don't know it, I'm toast on Wednesday. All right, let's start here. 30 degrees, 60 degrees, 45 degrees on the unit circle. Because I'm not giving you any of this. This is not on a reference sheet, nowhere. So 30 degrees, here we go. What coordinate do you have? Radical 3 over 2, 1/2. 60, flip it, right? Radical 3 over 2 and 45. Radical 2 over 2, radical 2 over 2. Yep, good. All right, still on the unit circle. X is equal to cosine value. Y is equal to sine. And don't forget this. Tangent. How do you find tangent? Because I'm out of coordinates now. You take the y coordinate and divide it by x coordinate. Yep. Which is the same as the sine over the cosine value. Yes, Jeremy?
Can we go over how to convert degrees to radians?
I can go over that in a second. Everyone all right here? Okay, let me keep going. Something not on the unit circle, making sure we know. Let's see, make sure we know what's positive where. Right? What's positive where? SOHCAHTOA, how to use that appropriately. And also what I showed you on Friday, which is the 3 new functions. What was anybody? Well, let's start with the easy one. What was paired with tangent? Cotangent, right? COT. Anybody remember what was paired with cosine? Remember second, right? Secant. And then what was paired with sine? Cosecant. And when I say paired with, how are these two related here? They're what of each other? I don't like the word opposites. Reciprocals. You got to flip them. All right. So if sine is 3/5, cosine will be 5/3. All right. It might just help your life out a little bit, make your life a little bit easier. The common degrees to radians. I'll write it, they're not needed, but I'll write it down here. 30 in radians, pi over 6, 45, pi over 4, 60, pi over 3, and then we go on the line, right? 90, pi over 2, 180, pi, 270, 3 pi over 2, and then 360, 2 pi. Yep. They're the common ones we've been using, because anything we do in degrees can be done in radians. Okay, so here are some of the topics. There is a page 2 that I can get to in a minute. If anybody wants to ask about one of these topics. Yep. Degrees to radians. Okay. Go ahead. Pick it. I don't care. Pick a degree measure.
420.
420 degrees. Okay. So I get 420, and I want to convert that to radians. What's the conversion? That's on the formula sheet, which you'll have.
180 over 5.
That's radians to. So I take 420. I multiply it by pi over 180. Remember, never will I accept a long decimal. So instead of accepting the long decimal, what do I like to keep in my answer to make it a little cleaner? I keep the pi in my answer, and what are you doing in your calculator now? So I don't put the pi in there, but I do put what in my calculator? 420 over 180 and reduce that. So let's see. Those will cross out 7/3, I'm going to say. Yeah. If anybody wants, there you go, 7/3. So 7 pi over 3. And that makes sense. If I look at this real quick, that makes sense. Ready? Pi over 3, what did we just talk about? Pi over 3. 60 times 7, 420. All right. I'll spend about half the class right now going over anything you see on here and you want an example of. And then the other half will be you guys just getting after it. Zach, what's up? What?
Can you go over F?
Where is secant, cosecant? Okay. Here's what I want you to do for me and your classmates. Because I don't think, because if I want to pick one that's actually in your packet if you have something there, but I don't think you do. Okay, so here's what I want, Zach, from you. We'll just make this up here. I'll do cosecant, secant, and cotangent. You give me, for each one, give me a degree measure on the line, a quadrantal angle. So cosecant of 90, secant of 270, cotangent
360.
So 0. Yeah, we usually don't use 360, but 0. Okay. All right, so here we go, guys. So let's help me find all these values. I don't know if one will come out to be undefined, but if one doesn't, I'll show you when it is undefined at the end. All right, everyone ready? Cosecant of 90. There's a couple things that got to go through your mind. Number one is, what's cosecant related to? Sine, right? All right, so I got to flip sine. So in my mind, I'm thinking I got to flip sine. The second thing is 90. You got to go to 90 and tell me what coordinate's at 90. That 1, 0 is at 0. That's 0, 1 right here. Okay, that's 0, 1 at 90. Okay. Usually, sine would be what? Which coordinate? So usually, the sine of 90 would be 1, right? 1 over 1. So watch what I'm doing here. Sine of 90 would be 1 over 1, correct? Flip it, though. Flip, cosecant 90 is going to be still what? 1. And you remember how to check it on your calculator. Everyone go to your calculator. You don't have a cosecant button, right? Anybody remember what we did on Friday to figure out a solution? I don't have a cosecant button. How did I use the sine button to find this value? So everyone ready? It's the same as 1 over sine of 90, which ends up being 1, right? So even if you forget, you can always rely on your calculator when it's on the line. Jeremy, question.
So why are you using 1 over 1 but not the 0?
Well, 0 is the x-coordinate. That's cosine. I'm not dealing with cosine. I'm dealing with sine. All right, so usually the sine of 90 would be 1. Flip it. Flip 1, what do you get? 1. Okay, maybe the 1 over 1 was a bad idea for me to write down, but the sine of 90 is just 1. Flip it, you still get 1. Okay? Secant of 270. Where's 270? What coordinate? 0, negative 1, right? Everybody good? All right, so secant's related to what? So cosine of 270 would be what coordinate up here? X coordinate, which would be 0. Okay, now watch. Ready? Flip it. You get secant 270. What happens when I flip 0 over 1? 1 over 0, which we can't have, right? Check your calculator. 1 over cosine 270. Error? There you go. So this is undefined. So I think what we're trying to find out is use your calculator, right? That's what if it's on the line, use your calculator on the test for anything. But you got to know how to type it in your calculator. So without going through all this, what about cotangent of 0? What are you guys doing on your calculator? 1 over tan 0. And we get, there we go. All right. Good questions. And I'm sure it'll be that'll be like a multiple choice, right? Which one of the following will be undefined? Anything else on this first page?
Can you do express a function as a positive acute angle?
Sure, you got it. Let's see, is there any in the, I believe there's definitely some in here. Can you guys go to number 17? 17, I think that's what we're looking for here. Nope. Sorry, I redid all these. Let's go to 15. 15. That's the one I wanted. 15. So I got cosine 655, and I want you to express it as a positive acute angle. All right, so it's still going to stay cosine. Is it positive or negative? 655. There's a couple ways you can do it. A couple ways you can see if this is going to be positive or negative. Find out what quadrant it's in and see if cosine's positive or negative there. A quicker way maybe, just type it in your calculator, right? Is that value cosine 655 positive or negative on your calculator? I don't care what it is. I'm not concerned about what it is, but is that positive decimal positive or negative? Everyone, it's positive on your calculator. All right, so I don't have to add in that sign. It's not needed. Now I need to get a angle, a positive acute angle. 655. Get me there. 655. What do I have to do first? Okay, go ahead. Subtract 360. I'm going to end up getting 295. I don't want that, do I? Why do I not want 295? It's not acute. I need acute. It says it right there, less than 90. You tell me, where do I keep going here? Find the reference angle. What quadrant's 295 in? 4, right? That's why it was positive, because cosine's positive in the fourth. How do you guys find a reference? And I'm going quick here because this is stuff I've done over and over again with you. Where's, it's in the fourth, so how do I find the reference angle? 360 minus 295. I end up with 65?
Yeah.
Okay. Cosine of 60 doesn't ask me to find the value. It just said write it as a positive acute angle. There it is. Please use the time you have on Wednesday to check your answers real quick. What do I mean? How could you check this answer to see if you're right or wrong? Put both in. The original, cosine 655, and the one you think is the answer, cosine 65. And they should be exactly the same. Use your calculator. I don't want the decimal answers, obviously, but at least you can use your calculator to check. And while we're on this page here, why don't we go down to number 17? Find the exact value. There are 3 of these. The last 3 questions on your test Wednesday are just like this. Find the exact value of this. Now, what do I mean by exact value?
Fractions or radians?
What's that?
Fractions or radians?
Fractions or not radians? Radicals.
Radicals.
Do I want you to just type this in your calculator and give me what it says? Absolutely not. Why would I have this on the test? You can just punch numbers in your calculator. All right, help me out. How do I get to the exact value of tangent negative 240? Here we go. Radicals, fractions. Well, let's start with it's negative 240. Anybody want to rewrite it? Okay, why don't we start by adding 360 so we can talk. Go ahead, add 360. This problem is the same as doing tangent of $120. Okay, talk to me. Tangent of 120 now. Find the value of 120.
It's in the second quadrant.
Let's start there. It's in the second. I got to start knowing if I'm positive or negative. Second quadrant tangent. Negative, good. So at least, I don't care how you remember. You write it down somewhere. You put a negative right now. I don't care where it goes. Negative. All right, I don't like the 120. I'm not familiar with 120.
The reference.
Okay, how about the reference angle for 120? 60. So I know I'm going to do 60 degrees and my answer is going to be negative. All right, what do you know about 60 degrees?
1/2 radical 3 over 2.
Good. Tangent.
I over x.
Tangent. Not x. Not y.
Y over X.
Y over x. So here we go. Negative radical 3 over 2 divided by 1/2 y over x. Keep talking to me because I'm not leaving that garbage as my answer. Yep. Negative radical 3 over 2. Change it to multiplication and flip the bottom. Good.
Cross multiply.
We got the 2's going. What do you got left on top?
Negative radical.
Negative radical 3. I don't know. Are we right? I don't know. How can I check if I'm right? Tangent, negative 240 equals that. Negative radical 3. Is that the same? Biggest mistake? You guys are going to forget the negative sign. But if you check, oh, the problem was negative, but my answer's positive. I better throw a little negative sign out in front. That's why I'm having you guys try to check. Yes, Jeremy.
Can you do number 18?
Sure, 2.5 radians. I have no idea, but I know where degrees and quadrants are. So what do you suggest I do to 2.5?
Convert it to degree.
Okay, how do I convert a radian to degrees?
180 over pi.
180 over pi. 99% of the time I can cross out pi's. Here, is that 1% I can't? All right, I cannot. There's no pi's to cross out. So everyone just doing 2.5 times 180 over pi. giving me about how many degrees that is? About 143 degrees. Can you tell me what quadrant we're in now? Yeah,
Second.
there you go. Quad 2. Hi, Laura.
Hi. Can you go over number 5?
Let's see. Ooh, baby, yeah. Oh, this is a good one. Well, while we're on here, you can cross off number 4, all right? Cross off number 4, that's a theta equals S over R problem. Not needed for this test. All right, what degree measure? Well, first of all, I have 4 choices. It's multiple choice, so if you had to just choose randomly, you have a 25% shot. Let's make our odds a little bit better. What quadrant is this angle in? Quadrant 3. Can you eliminate one of the answers for me right now? 143. Good. And it can't be 143. That's in quad 2. So now we just upped it to 33% if we had to guess, but we're not guessers. We're on the unit circle, right? We're on the unit circle. So what's that x coordinate mean? That's the cosine. And negative 0.8 is the sine. Using our calculators, how do we always find angles? An actual angle measure. What have we always done on the calculator? What have we used? The negative 1, right? Inverse. So now we got to make a decision. And I always say pick the positive one, but what's the problem here? There's not. Okay, so we're going to have to deal with it. So you guys decide. Do you want to do the x or the y? X. So I'm going to have to use what then? Cosine. All right, so we're going to have to go inverse cosine and plug in which of the 2 coordinates? Negative 0.6. Yep. This is tough. I hate being in the 3rd quadrant because nothing is positive there except for tangent.
Wait, so can we use tangent there?
You can, but you got to make sure you do the y over the x. Yeah, you can.
And both
If you can handle that.
negative?
What's that?
So negative 0.8 and negative 0.6 all need to be negative reference and
Correct.
tangent?
Yep. So you can do inverse tangent, the y divided by the x, if you want to handle that. So 2nd cosine, everybody, and what was our negative 0.6? Are we all getting, no, 126?
Yep.
Is that what everyone's getting? Okay. Problem though, right? What's my problem? That's not, well, first of all, even if it was an option, I'm not picking it. Why? What quadrant am I in? 3. Where's 126? All right, so here's the deal. Can we get 126 into the 3rd quadrant? You don't think you can, but you can. The reference angle is always the same in every quadrant, no matter where I'm at. So if you can find me the reference angle in quadrant 2, it's the same reference angle in quadrant 3. What's the reference angle for 126? 126. Reference angle? It's 54, which means that's also the reference angle in quadrant 3. So if I have a 54-degree reference angle in quadrant 3, how do I find the angle that I'm looking for now? 180 plus 54. I don't think it'll come out. I think we rounded a little too early, but it'll come pretty close to my answer, which is, what's that, 234? Yeah, so 233.
So if we get an answer like that, and we see our closest answer, can we pick that answer?
Well, the problem was we probably should have used 127 here and not 126, right? Because that would have rounded. So that was if we used 127, we would have been fine. Okay, so we just got to use our rounding directions. Jack, go ahead.
If you were to use inverse tangent,
Yep, go ahead.
what would you do for that?
Okay, so if I did inverse tangent, get my fraction template. What do I have? Negative 0.8, right, as my y divided by my x, 0.6. It'll give me the reference angle.
Okay.
There's your reference angle. Because remember, your calculator does not know what quadrant you're in. So it'll just give you a reference angle. So 53 is my reference angle. 53, 180 plus 53, 233. Okay? That's why I always have you guys use a positive. If you use the positive version of anything, it'll give you the reference angle automatically. Yes, Jeremy.
Can we go through, co-terminal and terminal?
Okay, coterminal is just, which of the, is coterminal, meaning it's the same angle. So what am I asking you to do to 825? It's coterminal means the same angle again. So what have we been doing to anything bigger than 360? What have we been doing really? Keep subtracting 360 till I hit my answer up here. All right, so that's all that one is. Okay?
And then terminal?
So 7 pi over 3. Well, that's in radians, right? What's pi over 3? 60 times 7. That's equal to 420. So basically, same question you just had for number 3. Keep adding or subtracting 360, and we'll get to which has the same terminal side as 420. Okay? All right. I think I've talked long enough up here. We have another day of review tomorrow, and I can get to the second day here. I will put all these topics up on Classroom, probably as you're working right now. All those answers to those problems are up on Classroom. Okay, all the answers are up on Classroom. There are a few, let me just tell you right now, that you don't have to do that deal with theta equals S over R, so let's just roll through those so you can cross those out. Number 9 can be crossed out. And I think, and number 20, that's theta equals S over R. Okay, number 20. Number 23 could be crossed out. That's just a basic right triangle sine cosine gambit. So that can be crossed out, 23. Everything else is fair game. Bump around, get your Chromebook out, find out where the answer keys are. I will put these up on Classroom right now, all these topics. Work with whoever you'd like, but got to be productive.